Slack is an obvious practice that is used by every human being. So, what is a Slack? The idea is to include minor tasks in whatever planning that you're having that could be easily dropped. So, these are minor tasks, or these are small tasks, non-important, non-priority tasks that could be easily dropped if you don't have the time to address them. The idea is to keep the commitments that you made to the customer. You have compromised yourself that you will deliver a couple of features and you should keep that commitment. If you have the time and if you are able to include some minor tasks in your planning, great. Nothing harmful will happen if they are not completed. So you can easily drop them. Include a Slack in your schedule. 10-minute build. This is a very specific practice that implies that the whole system should be built and all the tests of your system should run and pass in 10 minutes. So this is the ideal version of this practice. Basically, you have a system, you build it, you run all the tests, and you achieve this within a 10-minute interval. Software has few certainties, so this 10 minutes period is or should be seen as an indication of the time period that should be attained, but should not be strict, okay? More valuable than builds that require manual intervention. What this means is actually that when you automate a process, you make it free from human intervention. So if this could happen on an autonomous and on an independent basis, it will not have to be addressed by a human. And this removes the burden of work from the shoulders of member of the team. So it's good to have an autonomous process built into your work dynamics. Continuous integration. Recently, the DevOps movement has taken a lot of visibility in the community regarding to agile practices. Sometimes, even very important and core members of the movement seem to forget that continuous integration is one of the basic building blocks of DevOps, and this was already established in eXtreme programming back and back. What is continuous integration? Whenever you have an integration of software, well, basically because you have several teams writing several lines of code that should work very good together with one another, you have a nightmare because people don't have the same coding style. And the longer you take to integrate different portions of code that were written by distinct programmers and distinct teams, and you need to address and you need to put them all together, you will have an enormous risk when you try, if you take too long before you start to integrate the work of each member of the team. Integration usually takes more time than programming. A team that programs usually divides and conquers and integrates. When you have a team of people, you usually have more than one person coding. Each person or each team or sub-team works on a specific part of the software to allow for the parallelization of work. And then one of the things and one of the aspects that is required is to actually put them all together and integrate the results. You can either do this using approaches, so asynchronous approaches, or you can do this using synchronous approaches. When you have asynchronous approaches, you check in your changes and everyone checks in the changes. You build, the entire code, you test the entire product, you report problems by email, SMS, or even in some development teams, you can have a visual element like a red lava lamp that flashes whenever something is wrong. Or if you have a green one, it flashes because everything went okay. When you're doing a synchronous mode to integrate the work done by several members of the team, the idea is that after each coding cycle, you usually wait for everyone and you put the team on a break, and no more than a couple of hours, okay, you wait for the results before you progress with your code. Obviously that when conducting a synchronous integration, you are improving your performance or not, okay? Because you will probably have more difficulties that you have to overcome. When you're doing a synchronous integration, you have a lot of waste because you have to put your team on hold right before the team can actually improve and start working once again. Test first programming. This has evolved and currently is called test driven development. The idea is to write an automated test before changing any code. And this is true when you start writing your first feature. Before starting to write the code of a feature, you should write an automated test for that feature. What are the problems that are addressed with this technique of writing a test first approach? Basically, you actually know and you define the scope of your feature because you are addressing all the boundaries and all the values that enter for a specific feature. You test and you demand that both the code that you are writing and the test that you are writing are loosely coupled because they aren't completely dependent on one another, but cohesive because each functionality will work on an autonomous way, and each test will also allow you to test each functionality in an autonomous way. So yes, this is actually something that needs to be addressed because it has a direct impact in the software architecture that you are developing, and tests, automated tests, help you as a developer to do this. Besides that, also the trust issues that you have in your code, okay? Yes, you like your code, yes, you think you are a great programmer, a great developer, but you are a human. So you need to trust your code. And when you write an automated test, you are ensuring yourself that the code that you are writing is correct, or at least is consistent and you have the same errors in both sides. For the rhythm, whenever you are writing an automated test and then developing the corresponding feature, you are applying a cadency, a frequency of your software development, and that frequency is directly related to your work, to the work of your team, and the work of the project. By doing this and applying this frequency, this rhythm, you are applying continuous testing. Every time you write new code, you write a test. Whenever you need to deliver something to the customer, and that something implies functionalities, software product that actually works, you can apply a regression testing approach. What is a regression testing approach? Since you have all those automated tests written, once you deliver the software product as a living product to your customer, if you run all the tests will ensure you that at least for those scenarios that were tested, no bugs were found. This does not imply that the code has no bugs, okay? This only implies that the tests that were made, all the tests passed, show that for those scenarios, no bugs or defects were found. When you introduce a new code and you write a new test, if something happens, so if one of the tests fail, you know exactly what updates have you made, because since you are doing this on a very short period of time and you are introducing new features that are rather small, every time that you upgrade your software product, you know exactly the last changes that you made. So if something broke, you know exactly where to look for. So the regression testing enables you to find defects and bugs sooner and better in a more effective way. What are the alternatives for test-first programming or test-driven development? Could be something like manual testing be achieved? Yes, but it will not only cost more, because a human doing all those tests will definitely have a higher cost than conducting automated tests, but it will also not allow the tester, the human tester, to actually make some productive work, because there are a couple of tests that are quite repetitive. So even if you are a tester, a human tester, you should learn how to automate the tests.